morning students. Today we will continue with chapter 2 motion. In the previous class we have done what is uniform motion, what is non-uniform motion. We have done what are scalar quantities, what are vector quantities, right? And as examples we have started with distance and displacement, right? We have covered that what is distance, what is displacement. I hope you remember that distance is scalar whereas displacement is vector. Today we will do another set of examples from scalar and from vector. One from scalar, one from vector, okay? So from scalar we will do speed. Speed is a scalar quantity, I hope you remember. And from vector we will do velocity. Okay. Fine. Suppose you and your friend are running in a race. You have started to run. This is the end point, okay? And your friend has also started to run. You find that your friend has reached the end point earlier than you have. So what do we say? That your friend is faster than you. So we are using the word faster, right? So there comes the physical quantity speed. Speed is such a physical quantity which will measure how fast the object is, how fast the object is moving, okay? That means I can say that speed is the distance covered by time taken. That means if you cover less distance in the same time and your friend, suppose you cover, say for example, you cover 5 kilometers in 2 minutes, 2 seconds, or say 2 hours. And your friend covers 7 kilometers in 2 hours. That means your friend is faster, right? That means your friend will reach the end point faster than you will reach. Because your friend is covering more distance in the same time. Again, if I say that means distance is more, speed will be more. Again, if I say that you are covering 5 kilometers in 2 hours and your friend is covering say 5 kilometers but in 1 hour. Who is faster? Your friend, because he or she is taking less time to cover. Less is the time, more is the speed. Fine. So speed depends on distance and time. And it is given by distance covered by unit time. What can be the SI unit of speed then? The SI unit of speed will be, distance SI unit is meter, by time the SI unit is second. Meter per second, or we can also write it as meter per second. Okay? And obviously, we have bigger units of speed also. I can write my speed in kilometer per hour. If I can write speed in kilometer per hour, I can convert from kilometer per hour to meter per second. These are bigger units of speed. If suppose for this one, I am using kilometer per hour. And if I say you are covering 2 meters in 4 seconds. So, speed will be 2 by 4 meter per second. Okay. And in this case, 5 by 2 kilometer per hour. Fine. So, this is about the speed. Now, let's come to the two different cases. Speed can be uniform and can be non-uniform. Uniform means suppose you traveling. You are walking 1 kilometer in the first 1 hour. Again 1 kilometer. Again 1 kilometer in the next 1 hour. See, you are covering equal distances in equal interval of time. So, you will have uniform speed. But if you travel 1 kilometer in the first 1 hour, again say 3 kilometer in the second hour, that means the next 1 hour, again you become slow and you cover 1 kilometer in the next 1 hour. So, are you covering equal distances? No, you are covering unequal distances in equal interval of time. So, you are possessing, the speed which you possess is non-uniform. That means, uniform means it will remain same throughout. Non-uniform, it does not remain same throughout. So, if I ask you, say this is you and this is your friend. If I ask you what is your speed, you will say my speed is 1 kilometer per hour. You can easily say 1 kilometer per hour is my speed, because see, every time it's the same. But what about your friend? What will you say? What is the speed of your friend? How will you tell me? How will you give me the answer then? You will have to say, okay, my friend's speed is 1 kilometer in 1 hour, 3 kilometer per hour in the next interval, 1 kilometer per hour in the third interval. Will you say like this? No. We can say in a short form. How? We use the term average speed. When your friend is moving unequal distances in equal interval of time, that means the speed is not same throughout. We can use average speed to tell his or her speed. What is average speed? The total distance travelled by the total time taken. What is the total distance travelled by your friend? 1 plus 3 plus 1 kilometer by the total time taken. 1 plus 1 plus 1 hour. So, 5 by 3 kilometer per hour is the speed of your friend. Average speed of your friend. Okay? This was about uniform, non-uniform and average speed. Now, let's come to velocity. Velocity is defined as, again, the distance travelled per unit time. Then what is the difference from speed? Speed is also the distance travelled per unit time. The difference is velocity also has a direction. Velocity has a direction. That means the distance travelled by unit time in a given direction. Here comes the difference between the speed and velocity. Otherwise, you will find that mathematically velocity is equal to distance by time. So, what will be the unit? Distance SI unit is meter by time second. So, meter per second. Then speed also has the same unit. This unit speed also have. Then the difference is they are not same physical quantities. The difference is velocity has a direction also. Okay? Unlike speed, which only has magnitude, no direction to specify. Now, suppose you are walking in the first 2 seconds, say 5 meter. In the next 2 seconds also 5 meter. In the next 2 seconds 5 meter. And also in the same direction. Moving in the same direction, not changing any direction. That means the magnitude of, that is the distance traveling, you are traveling in each time interval remains same, as well as the direction also remains same. Then we call that uniform velocity. Okay. Then what is non-uniform velocity? Suppose you have actually 3 cases of non-uniform velocity. Say you are traveling 5 meter in the first 1 second, again the next interval 5 meter, again 5 meter. Okay, 5 meter, then say 7 meter, then again say 6 meter. But in the same direction. Okay, so what is changing? You are covering unequal distances in equal interval of time, but in the same direction. In this case also non-uniform velocity, because one of the factors is changing, the distances. Okay, this is the one case for non-uniform velocity. Another case, say you are traveling 5 meter in 1 second, 5 meter in the next second, again 5 meter in the next second, but direction keeps on changing. How is that possible? For example, you are moving in a circular path. Say, each point the direction actually changes. Okay, direction does not remain the same. Basically, you are covering equal distances in equal interval of time. But what changes? Direction changes. In this case, the distance itself changes, but the direction remains same. Then also non-uniform velocity. Why? Because velocity, you remember, depends on, it has, in order to describe velocity, we need magnitude as well as direction. Any one of them changes, velocity will not be uniform. In this case, direction is changing, so non-uniform velocity. Now suppose you are moving 5 meter in the first say in 2 seconds you are moving in this direction. In the next 2 seconds you are moving 5 meter, say 7 meter in the other direction. Again, say 6 meter in the next 2 seconds in another direction. Both changing. See, distances, unequal distances, it is covering unequal distances in equal interval of time, as well as the direction is also changing. This is also non-uniform velocity. So these are the 3 cases of non-uniform velocity. Okay. So we have covered speed and velocity, whatever was there. So let's just keep our class up till this for today. Okay. In the next video, we will do mass and weight. And after we are completed with the chapter, we will do numericals. You will get numericals from speed. You will be given distance or time, you have to calculate speed, or say distance, you have to calculate speed and time given. Also you will get displacement, distance, numericals from there. So we will practice those numericals once we finish the chapter. So that's all for today.